Hi, today in this class we are going to learn what is meant by relative atomic mass and what is meant by relative molecular mass. As well as we'll see some examples of that, how to calculate the atomic molecular mass. After that we'll see percentage composition, the meaning of that as well as how to calculate that we'll see with the help of some examples. But before going to understand what is meant by relative molecular mass or relative atomic mass, we need to understand what is meant by atomic number, what is meant by atomic mass number. First we'll see what is meant by atomic number. Atomic number represented by letter Z. Atomic number of an element is equal to the number of protons present in the nucleus of its atom. Now we know that in each atom there are how many subatomic particles? 3 subatomic particles are there. Which are those? Neutrons, proton, electrons. These are the 3 subatomic particles which are present in each and every atom. Neutrons and protons, they are present inside the nucleus of an atom, and electrons are present outside the nucleus. We know that the charges of those subatomic particles also, proton is having positive charge, electron is having negative charge, and neutron is chargeless. But here this atomic number definition tells us that atomic number is nothing but the number of protons present inside that atom. Now we'll see with the help of example. Atomic number of hydrogen is 1. Here this is the structure of hydrogen. Here also 1 proton is present inside the nucleus and 1 electron is present outside the nucleus in hydrogen atom. Here atomic number is also 1 and number of protons are also 1, and that's why it shows that atomic number is nothing but the number of protons which are present in that element. For example, the atomic number of carbon is 6, means how many protons inside that carbon? 6. If atomic number of oxygen is 8, means how many number of protons in oxygen? 8. We'll take one more example. If number of protons in sodium are 11, then what is the atomic number of sodium? Find out the answer and give me answer in comment box. Next we'll see what is mean by mass number. Mass number we are represented by using letter A. Mass number is the sum of the number of protons and neutrons present in the nucleus of an atom. Just we learned that atomic number is the number of protons present inside that atom. But the mass number is the addition of both number of proton as well as neutrons, which is equal to the atomic mass number. Means how many number of protons and how many number of neutrons present in that atom. Addition of both protons and neutron is known as atomic mass number. For example, in carbon atom, 6 protons are there and 6 neutrons are there, which is equal to the 12, and 12 is nothing but the atomic mass number of carbon. This lower 6 denotes the atomic number, which is number of protons, and this superscript number shows that the atomic mass number, which is equal to the addition of proton as well as neutrons. Relative atomic mass means what we are actually doing. It is difficult to calculate the mass of any object. That's why in our day-to-day life also we are comparing the masses of 2 objects, which is easy as compared to calculate the mass of any object. And we are comparing the masses with mass of other object. That's why we are saying that is a relative atomic mass. Here the mass of one hydrogen atom is equal to the 1.66 into 10 raised to minus 24 gram. But this number is difficult to remember as well as to represent anywhere. That's why instead of this mass we are using 1 atomic mass unit. 1 unit to represent this number we are using, and this is the mass of hydrogen. That's why the mass of 1 hydrogen we are writing as a 1 atomic mass unit. AMU is the abbreviation of atomic mass unit. In a grocery shop also, that person what he is doing, he is comparing the masses of rice, wheat with 1 kg, 2 kg mass of that stone. Same like in chemistry also, what we are doing, we are comparing the masses with one standard element. Initially, scientists decided to take hydrogen as a standard element, but hydrogen not react with many elements. That's why after some experiments, scientists decided to take carbon as a standard element because it is having capacity to combine or react with many elements to form a different types of compounds. That's why they did experiment that one hydrogen is equal to how many carbons. And when they did this experiment, they observed that 12 hydrogen atom is equal to the mass of one carbon. That's why we are comparing these masses with carbon, and the mass of one carbon is equal to the 1/12 mass of one hydrogen. And that's why in definition we are writing that the relative atom mass of an element is the average mass of the atom of that element as compared to 1/12 of the mass of one atom of carbon 12 isotope. Here also see the one nitrogen, or the mass of one nitrogen is equal to mass of 14 hydrogens. Here also we are comparing the masses of two types of atoms, and that's why the term we are using as a relative atomic mass. Simply we are not using atomic mass because we are relate the masses of two elements, two atoms. That's why we are using term relative atomic mass, and the unit for relative atomic mass is atomic mass unit. In short, we are using AMU. The mass of one hydrogen is equal to 1 AMU. The mass of one carbon is equal to 12 AMU because 12 hydrogen atoms mass is equal to 1 carbon mass. Now we understand what is meant by relative atomic mass. We'll see what is meant by relative molecular mass. We know that what is meant by molecule? Two or more atoms combine to form a molecule. Same like that, if you want to calculate the relative molecular mass, what we are doing? How many atoms are present in that molecule? We are doing addition of the masses of those all the atoms. We'll see with the help of example. That relative atomic mass is equal to relative mass of atom. Oxygen atom, that is relative atomic mass of oxygen is 16. Now here oxygen molecule is given. Oxygen molecule, in that two atoms of oxygen are there. That's why we are doing addition of each mass of oxygen. Mass of one oxygen is 16 and mass of second oxygen is 16, which is equal to the 32. And that's why the relative molecular mass of oxygen is 32. Relative molecular mass is the mass of one molecule of an element or a compound compared to that of 1/12 of the mass of atom of carbon C12. The relative atomic mass of carbon 12 is taken to be 12. Why we are taking here 1/12 of mass of carbon? Because the mass of hydrogen is equal to the mass of 1/12 of mass of carbon. The mass of hydrogen is equal to the mass of 1/12 part of the carbon. That's why we are taking 1/12 of the mass of carbon C12. Once again we'll see the relative atomic mass or atomic weight. For relative atomic mass, we are using one more term, that is the atomic weight. Of an element is the number of times of one atom of the element is heavier than 1/12 times of the mass of an atom of carbon 12. Thus, relative atomic mass is equal to the mass of one atom of element, which is equal to 1/12 of the mass of C12 atom. When we are taking mass of any element, that is divided by 1/12 mass of the C12 atom, and that is nothing but the relative atomic mass. Atomic mass is expressed in atomic mass unit, in short AMU. Atomic mass unit is defined as 1/12 mass of carbon atom C12. C12 is an isotope of carbon. There are two isotopes of carbon, C12 and C14. the mass of an atom of carbon C12 isotope was given the atomic mass of 12 units, and which is nothing but the 12 AMU, or simply 12 U we are using. Relative molecular mass. For that we are using abbreviation RMM. Relative molecular mass or molecular weight of an element or a compound is a number of that represent how many times one molecule of the substance is heavier than 1/12 of the mass of an atom of carbon 12. The relative molecular mass is obtained by adding together the relative atomic masses, atomic weights, which are of all the various atoms present in a molecule. For example, in any molecule, how many atoms are there? We are adding all the masses of those atoms, then we'll get the relative molecular mass. Now we'll see some examples that how to calculate the molecular mass. First, that is a copper sulfate crystal. What is the molecular formula is? That is CuSO4 5H2O is its molecular formula. And now how to calculate its relative molecular mass, we'll see. What is given here? The mass of copper is given, sulfur is given, oxygen, nitrogen, all the things are given. How many coppers are there? Only one. That's why we are taking mass of copper, that is 63.5 here, plus mass of sulfur, that is 32. Mass of oxygen, here how many atoms of oxygen are there? 4. That's why we are doing 16 into 4 plus 5, and 5 is written before H2O, means 5 molecules of H2O here. What is the mass of H2O? 18. That's why we are doing into 5 molecules of water. That's why 5 into mass of water we are doing, and it will get, that is 249.5 after calculation. This is nothing but the molecular weight of copper sulfate crystal. Now we'll see second example, that is ammonium sulfate. Here NH4 twice SO4 is a molecular formula. When 2 is written outside the bracket, the meaning is that the atom which is present inside the bracket, for every atom this is written 2, means number of nitrogen are also 2, number of hydrogen, that is 4 to the 8 here in this molecule, 1 sulfur and 4 oxygen. Now the masses of atoms are given here. Only put up the values. N2H8SO4. Mass of nitrogen is 14. 2 nitrogens are here, that's why 14 into 2. Hydrogen, the mass of hydrogen is 1. 8 hydrogens are there, that's why 1 into 8 we are taking. 1 sulfur, mass of sulfur is 32. Mass of oxygen is 16, and 4 molecules of oxygen, so 4 atoms of oxygen are here, that's why we are doing into 4, and after doing whole calculation we will get 132, which is the relative molecular mass of ammonium sulfate. We'll see one more example, that is cane sugar. The formula for cane sugar is a C12H22O11. Relative molecular mass of cane sugar is, how many number of atoms here? Carbon 12. 12 atoms of carbon are here. That's why 12 into 12. Mass of 1 carbon is 12. That's why we are doing 12 into 12. Mass of 1 hydrogen is 1. Here how many hydrogens? 22. That's why 22 into 1 we are doing. And mass of oxygen we know that 16, and we are doing into 11 because number of oxygens are 11 here. And after doing calculation we get a 342 is a relative molecular mass of cane sugar. Next we'll see percentage composition. Percentage composition of compound is a percentage by weight of each element present in. For example, water is there. What is the percentage of hydrogen in that water? What is the percentage of oxygen in that water molecule we need to calculate? We'll see with the help of example how to calculate that. Percentage of an element in a compound, that is total weight of the element in one molecule upon gram molecular weight of the compound into 100. Here we are calculating percentage, that's why doing into 100. We'll see some examples how to calculate the percentage composition. See, Calculate percentage of hydrogen in water. Given that the relative atomic masses, hydrogen is 1 and the relative atomic mass of oxygen is 16. Mostly in exam also they will provide the atomic masses. So don't worry about how to calculate the molecular mass and percentage composition. Here the relative molecular mass of water is 18. Since 18 gram of water contains 2 gram of hydrogen. What we are doing here? We are calculating the mass of hydrogen. 2 atoms of hydrogen. That's why mass of hydrogen is 2 gram. That's why 100 gram of water contains 2 upon 18 into 100. With the help of this formula, we are putting the values. Total weight of element in one molecule, that is 2, and the gram molecular weight of the compound. Gram molecular weight of compound is 18, that is water mass. And 2 upon 18 into 100 is equal to 11.11 gram of hydrogen. Means in water molecule, how many grams of hydrogens? 11.11 gram of hydrogen is present in water. Answer: hydrogen in water is 11.1%. Whenever in your exam they will ask question like that, you should write answer at the end like this. Calculate the percentage composition of various elements in sodium carbonate. Now the formula for sodium carbonate is Na2CO3. Here the masses of sodium, carbon and oxygens are given. That's why first, whenever percentage composition is there, we need to calculate the mass of that whole compound, and which is nothing but the 106. Why 106? See, the mass of one sodium is 23. 2 sodiums are there, that's why 23 into 2. Next, 1 carbon is there, that's why addition of 1 carbon we are doing, plus 3 oxygens are there, mass of 1 oxygen is 16, that's why 16 threes are we are doing. And after whole calculation we get the molecular mass of sodium carbonate is 106. Since 106 gram of sodium carbonate contain 46 gram of sodium. Now we know that the mass of sodium is 46 and mass of whole compound is 106. That's why now we are calculating percentage of sodium in that compound. That is 46 upon 106 into 100, and it will get 43.4 gram of sodium. The percentage of sodium in that compound is 43.4 gram of sodium. Similarly, now we want to calculate the percentage of carbon here. Then we are doing 12 upon 106, because mass of that element divided by mass of whole compound we are taking and doing into 100, and it will get 11.3 gram of carbon. Again 106 gram of sodium carbonate contains 48 gram of oxygen, and that's why we are taking 48 upon 106 into 100, and it will get 45.3 gram of oxygen. That's why in Na2CO3, Na is 43.4%, carbon is 11.3%, and oxygen is 45.3%. In this way, in this class we learn about what is meant by atomic mass, what is meant by relative atomic mass, what is meant by relative molecular mass, and what is meant by percentage composition, and we learn examples of all that how to calculate all these things.